In the last class, we studied about this translation vector. Two non-collinear translations defines the plain lattice. ಎರಡು non-collinear translations ಅದಾವ ಅಂತಂದ್ರೆ plain lattice ಹೇಳ್ತೈತಿ. If three non-coplanar translations are there, it defines the space lattice. Okay. If two are there, plain lattice, then if three are there, then it is space lattice. Then now question arises that which pair of translation does helps to describe the translation, whether it is plain or space lattice. Okay. In fact, there are infinite lattice points are there in crystal to choose the translations, because the line joining of any two lattice points is translation of the lattice. Okay, let's show some plain lattice. Okay, let's show some plain lattice. We can choose any lattice points. This is A and this is B. Okay, then this is a lattice plane. We can choose in different direction also. So I can choose these two lattice points to make translation. This is R A1 and this is B2 and this is a second plane lattice. The geometrical shapes will changes according to our chosen lattice points. So some of we can go for this B3 and this is the one more lattice points. This is, let's call this as A3. Okay, this is one more plane lattice. Okay, then here you can choose one more translation A4 and this is B4. Here the geometrical shapes are changed because of the lattice points. This is the plane lattice. Okay, then unit cell. Unit cell, it is defined as the smallest volume. Already we discussed unit cell is the smallest volume which is repeated in all direction to build the crystal. ಇದು ಯೂನಿಟ್ ಸೆಲ್ ಅನ್ನೋದ್ರೆ ಏನು, ಒಂದು ಸ್ಮಾಲೆಸ್ಟ್ ವಾಲ್ಯೂಮ್ ಇದು which build in all direction. This is the all direction ಒಳಗೆ ಇದು ರಿಪೀಟ್ ಆಯಿತು ಅಂದರೆ there will be forms a crystal. So we can call this as unit cell as a basic building of crystal. Unit cell is also called as basic building of crystal. Basic building of crystal ಅಂತಲೂ ಹೇಳ್ತೀವಿ. Okay, then unit cell in three dimension, how it looks. It can take any form. These are the some lattice points. Okay, so if I make this as a reference, it in all direction and in this direction. So it looks like this in 2D. In three dimension we can take this as like this. Sorry, in 3 dimension it looks like this. This is plane, or in plane it looks like this only. Okay, then how it repeats, let's see. These are the some lattice points. Okay, this is a unit cell in plane. If we consider this is in plane, unit cell is in plane. Okay, then in 3 dimension it look like this. These are the 4 lattice points. Okay, Here is a one more lattice point. Okay. The repetition. It is the basic building of crystal. ಇದು ಒಂದೇ ಯೂನಿಟ್ ಸೆಲ್ ಐತೆ ಹೌದಾ. ರಿಪಿಟೇಷನ್ ಆದರೆ ಇಟ್ ಬಿಲ್ಡ್ಸ್ ಕ್ರಿಸ್ಟಲ್. ರಿಪಿಟೇಷನ್ ಯಾವ ಥರ ಆಗುತ್ತೆ? ಸೊ ಲೆಟ್ಸ್ ಸಿ. Here is a lattice point, here is a lattice point. This is the like this in all direction it is going to repeat. This is the basic building of crystal. Then it gets lattice point or space lattice. Okay, how to arrange these? How are the lattice points, or sorry, how are the unit cell are arranged? So it is the plane, we know each set of plane. Okay, this is one plane, some more here another planes are there. Each parallel plane is divided the spaced and parallel, but planar distance is may vary or differ. It is depend on the size and shape or identical in lattice corner. The corner point of intersection in three dimension lattice point, that is called as lattice point. Lattice points are all corner points only that forms the line lattice. Okay, whole arrangement of this lattice point, the corner one, this is the lattice point. The whole arrangement is like this only. The spacing of parallel like this. Let's draw some figures. So this is a one plane, another plane, third plane, fourth plane, like this. The n number of planes are there. The distance may vary from one lattice point to another. Distance may vary. Okay, here this is the A. The distance of this lattice point to this lattice point is same, A. If the lattice points from this point to this point, another lattice point, this is B. The length of each lattice point in horizontal direction, let's consider for the understanding purpose. If we consider these two lattice point, the distance is A. If these 2 point distance is A, from this point of lattice point to this point lattice, the distance is B. Okay, the distance may vary from each direction. Okay, the angle between them, and the last class we studied this, angle between them is may equal to 90 degree or may not equal to 90 degree, that we know. So how it equal to 90 degree, how does not it equal to 90 degree, or else some other maybe 120 degree, how does it varies? It varies it all from the plane. It is a one plane. Okay, here number of lattice points are there. Similarly these planes will be changing. Okay. Okay, then in the last class we studied this. Okay, this is the unit cell. Okay, this is the direction C, and this is the direction of B, and this is the direction of A. Here is a lattice points are there. It is a unit cell. The distance between each lattice point in three dimension, from this is the corner point. Let's consider this corner point. From this lattice point to this lattice point, the crystallographic axis from in the B direction, the length is A. Okay, let's consider this as capital B. This is the unit length is B. From this point in the axis of A, from this point this lattice point to this lattice point, the unit length is A. In the direction of C, the unit length is C. This is what we learned. So this is alpha, and this is gamma, and this is beta. The angles between the each axis, crystallographic axis, is alpha, beta, gamma. This A, B, C and alpha, beta, gamma are called as lattice parameters. They are called as lattice parameters. Or else lattice constant ಅಂತಲೂ ಹೇಳ್ತಾರೆ. These may vary or different. Okay, in the direction of B, the length is different. In the direction of C, the length is different. In the direction of A, the length is different. The angles may be equal to 90 degree or else may not be equal to 90 degree. Then how this crystal structure, how this unit cell will be framed? We know this space lattice or point lattice. Okay, the space lattice, point lattice we know. Okay, here the another word we will introduce, that is Bravais lattice. Bravais lattice. The plane, here is a plane. Okay, the plane, if we considered in ವಾಲ್ಯೂಮ್ ಸ್ಪೇಸ್, ಇಟ್ ಈ ಪ್ಲೇನ್ ಐತಿ, ಇದು ವಾಲ್ಯೂಮ್ ಸ್ಪೇಸ್ ಒಳಗೆ ಕನ್ಸಿಡರ್ ಮಾಡಿದರೆ ಯಾವ ಥರ ಆಗುತ್ತೆ? Okay, this is a plane. Here n number of planes are there. Let's join these some points. Okay, this is the one plane, second plane, third plane. These are the three planes are there. This is the one plane, first plane, second plane, third plane. These are the three dimension. This is the three dimension space. Why? Because we are considered it in a volume space. ಇದೇನಿತ್ತು, ಪ್ಲೇನ್ ಇತ್ತು. ಇಫ್ ವಿ ಸ್ಟಡಿಡ್ ಇನ್ ವಾಲ್ಯೂಮ್ ಸ್ಪೇಸ್ ಒಳಗೆ ಸ್ಟಡಿ ಮಾಡಿದ್ರೆ ಯಾವ ಥರ? ಇಟ್ ಈಸ್ ಡಿವೈಡೆಡ್ ಇಂಟು ತ್ರೀ ಸೆಟ್ಸ್ ಆಫ್ ಪ್ಲೇನ್. This is first, second, third. Three sets of parallel planes are there. These are the parallel planes. Okay. Let's choose one more plane here. This is the one plane, second plane. This is third plane. 1, 2, 3. Okay. Another plane is like this. First. One more. This is the plane. Okay. Here one more plane is there. Okay. These are the planes are there. Okay, it is divided in intersecting lattice. Here all the planes are intersecting here. Okay, so here is the intersection, here is the intersection. These all are the intersection points. These are the lattice intersection points are there. These intersection points will form the space point lattice. All the points, ignore these lines, just concentrate on these red color marks. These are the lattice points. If we divide it into smaller box or repetition of unit cell. Okay, this is the repetition of unit cell. This is the, okay, this is the unit cell. We know the repetition of unit cell. Here one more, here one more unit cell, here one more unit cell. So the same will be repeat here, the same will repeat here. If we consider in this direction, this is the one more unit cell. Okay, this is the one more unit cell. Okay, these are the repetition of unit cell. Unit cell, it is a basic unit cell which gives the basic information. What it gives? It unit cell. It gives the basic information about the material. Okay. Then one more, the ABC. This ABC, this is A and this is B, this is C. This ABC are the crystallographic axis. The distance of lattice point AB, capital ABC, are length. These are the axis. This is C and this is A. Okay, B. Sorry, this is C and this is B. The length of this A, B, C are the crystallographic axis. The distance between the point is this called as crystallographic axis. Then alpha, beta, gamma. This is alpha, beta and gamma. Alpha, beta, gamma are the lattice angles. These are the angles. The whole is called as lattice parameters or lattice constant. The value of lattice is vary for different lattice. These lattice parameters will differ from each lattice. Using the translation vector, here we can predict in this form also. There in the last class we had taken n1, n2, n3. These are the whole numbers. So we can predict in this way also. L1, LA, M, B, N, C. These are the vectors where L, M, N are the whole numbers including 0 and positive and negative numbers. Choosing all these combinations of N, L, M, N values. Okay. These L, M, N values will gives the crystallographic axis length. Okay. So if we consider here this lattice point, then what is the translation value of this lattice point? Okay, so this is a reference. We can say this as 0, 0, 0. Okay, this is the lattice point which is the having the value 0, 0. So this is our reference one. I'm going for here. Okay, this is in the direction of A. So the A value is 1 and there is no value of C and there is no value of B. So this lattice point value is 1, 0, 0. Okay. Then if I consider this lattice point, its value is the B length is here. The length of B we can measure here. Sorry, it is in the direction of C, you know. ಇದು ಸಿ ಡೈರೆಕ್ಷನ್ ಒಳಗೈತಿ. ಈ ಲ್ಯಾಟಿಸ್ ಪಾಯಿಂಟ್ದು ವ್ಯಾಲ್ಯೂ ಏನು ಅಂತಂದ್ರೆ ದೆರ್ ಈಸ್ ನೋ ವ್ಯಾಲ್ಯೂ ಆಫ್ ಎದು ವ್ಯಾಲ್ಯೂ ಇಲ್ಲ ಈ ಪಾಯಿಂಟ್ ಒಳಗೆ. ಸೊ 0. ಬಿ ವ್ಯಾಲ್ಯೂ ಇಲ್ಲ 0. ಸಿ ವ್ಯಾಲ್ಯೂ ಇದೆ 1. somewhere you consider this somewhere else. ಓಕೆ, ಸಮ್ವೇರ್ ಇಲ್ಲೆಲ್ಲೋ ಒಂದು ಪಾಯಿಂಟ್ ತೊಗೊಳ್ಳೋಣ ಅಂತ ಅಂದ್ಕೊಳ್ರಿ. ಓಕೆ, ಫಸ್ಟ್ ಲೆಟ್ಸ್ ಮೂವ್ in this direction. This lattice point value is A0, B1, C0. Okay, these are the lattice points value or else translational value of these lattice points. Somewhere here we can consider this point. ಈ ಪಾಯಿಂಟನ್ನು ತಗೊಂಡ್ರೆ ಏನಾಗುತ್ತೆ? Again the A value 1, 2, 3, 4. Sorry, this is 0, 1, 2, 3. 1, 2, 3, 0, 0, 1, 2, 3. The A value is 3. There is no B value, 0, 0, 0. Okay, this is like this. Okay, these are the translation vectors. Translation vector T value for this lattice point and these are the lattice points. Okay, in the next class, these Bravais lattice, the different types of Bravais lattice are there that we are going to study in our next class. Thank you.